But hey, that's okay. All right. So, like I said, we're going to put them in standard form and we're going to write some equations. So here we go. Now, first things first. I find the order up here a hot mess, okay? That they're scrambled up. So, nice thing about ellipses, always x first and then y. So the first thing I'm going to do is pair up the two x terms. So I'm going to keep the 9x squared. And I'm going to go ahead and put 36x next to it. Now I'm going to do the y squareds. So I'm going to put the 4y squared, 24y. And I'm going to go ahead and subtract 36 off. All right, now it's bad part. Before you complete your square, what's the lead coefficient need to be? Okay, 1, I heard it. So the first thing on the x's I'm going to have to do is take the 9 out. I'm going to factor 9 out. I don't want to divide everything by 9 because we probably have some fractions. Let's avoid that. So I'm just going to factor the 9 out. 9 times 4, 36. I'm going to put my blank in. So I'm going to keep my minus 36 over here. I'm just going to move it back a little bit so I have a little more room. Now complete your square in that green 4. Half of 4, 2, 2 squared 4. But I'm not going to get crazy and just put plus 4 on the right to balance it. I really put what number on the left? I heard it, 36. The 9 distributes. That is a very easy thing to miss, and it really messes up your equation. Okay, y's, I got to take the 4 off, but that's, not that bad. 4, let's take 4 out of that. 4 times 6 is 24. So I'm going to complete my square on 6. Half of 6, 3, 3 squared. But again, I'm not going to get excited and just slap a plus 9 on the right side to balance. You really put what number? 36. A lot of 36 this problem. I don't know why. Okay. Now, purpose, remember completing the square. You can now factor your trinomial. Multiply to 4, add to 4, 2 and 2. Let's do the blue y's. Multiply to 9, add to negative 6. Negative 3, negative 3. And the right-hand side totals up pretty nicely. 36. Now, one last thing I'm going to do before I start answering and graphing and doing all the stuff. Remember, ellipses, standard form, you have to be set equal to 1. So I'm just going to divide off this 36. I'm kind of running out of room, so I'm going to put the answer here next to the equation. I'm going to reduce 9 over 36. It's really 1 over 4. I'm just not going to put the 1. That's not necessary, of course. We know there's a 1 there. 4 over 36, 1/9. And, of course, equals 1. So obviously more work to get it into the form, clearly, but less homework problems then because it takes you a little bit to do this, okay? Now, center, same rules with circles, parabolas, all of it. Anytime you're in parentheses, you're going to switch the signs. Negative 2, positive 3. And let's go ahead and plot that. Okay, we'll get the vertices and all the other stuff. Mark it out just like yesterday. 4 is under x, square root of 4, 2. Left 2, right 2. From our new center here, 9's under y, square root of 9, 3, up 3, down 3. Got it. Try to draw your ellipse. All right, vertices. Are the vertices the left and right or top and bottom points?
Top and bottom.
Top and bottom, they're always on the major axis, the longer axis, it's vertical. So I'm going to jot down negative 2, 0 and negative 2, 6. And then how long is your major axis? Tall, it's vertical. So we went up, down, a total of 6. Up 3, down 3, 6. How wide is it? What's the minor axis? 4, 2 and 2. All right, got to do a little bit of work here, of course, to get our foci. That's that c squared equation. Now, again, just prepping you for when we get to hyperbolas. If you have a plus in your standard form equation, your foci is minus. Tomorrow, it's going to be flipped. So you always have opposite sign. Now, 4 minus 9, 9 minus 4, it's got to be 9 minus 4, so we have a positive. 9 minus 4, 5. And of course, we're going to end up square rooting that. So I punched it in earlier. It's about 2.2. Now remember the foci are on your major axis. It's vertical. So I'm going to go up 2.2. I'm going to ballpark it and down 2.2. Here's the hard part on this one. I need the foci points, those green points, exact coordinates. You can do it. Easy question. What's the x coordinate on both of them? -2. You can just look at it and see that. Now remember, we went from the center. Lydia, question, guys? We went from the center up a square root of 5 and down a square root of 5. So my center was at 3. I went plus root 5 minus root 5, which is what I'm going to write. That's the tricky part. All right, calculation for eccentricity. What's the formula?
C divided by A.
You got it. C square root of 5. And what is A, 2 or 3? 3, the bigger number. I just kind of couldn't cram it all in there, so I made my own little slashy fraction bar for that. All right. Any questions on that, guys? So nothing new or nothing to add as far as the graph goes, and you know how to complete the square, so I don't have a lot of new stuff for you. Okay, same thing. We need to reorder it. We need to complete the square. So first I'm going to keep the x terms together. I'm going to put the y terms together. And we're going to add 37. Same spiel as the last one. Before you complete your square, we need that coefficient, lead coefficient to be a 1, not a 12. I'm going to have to pull a 12 out. X squared minus x. I'm going to go ahead too, just to set us up here. I'm going to move my 37. I'm just going to kind of move it over a little bit so I have some room. Now, it's going to be fun. Complete your square on 1. What's half of 1? Half. What's 1/2 squared? 1/4. Yes. Okay. Now, I'm not going to put a 4th over there. I really put what number? 3. 12 times a 4th. That's not so bad. That's not so bad. Okay, y's are nice. Take the 20 out. 20 times 2 is 40. And now complete your square on 2. Half of 2, 1 squared, 1. But again, I really put 20 times 1. So you got to be careful there about balancing out the appropriate number. All right, let's see how good we can factor. What multiplies to a quarter and adds to -1? What fractions? Multiply to a quarter, add to -1. Half, yeah. It's going to be minus. Now, is that the best to have to graph and deal with? Is it the worst? No, could be better, could be worse. It's one of those days. All right, y plus 1 then. And let's add up our right-hand side. Let's see, 37 plus 3 puts you at 40. 40 plus 20, 60. And the last thing I got to do, to finally get this in standard form, I'm going to divide the 60. Clearly, I'm running out of room. I'm going to put it over here on the side. 60, not 16. I said 60. And then it's going to get fun. Because what's 12 over 60 reduced to? Yeah, okay, all right. Fun. So I'm just kind of cringing because 5 is not a perfect square, so it's going to be a little dicey for us to draw, but we're going to make it happen. 20 over 60 reduces to a third, which again, I'm cringing just a little bit because 3 is not a perfect square. So this is going to be a really good one to draw. Feel my sarcasm. Okay, center. What's your center?
1/2.
Okay. And yes, that is hard to graph exactly. Estimate it very best you can. Olivia.
Would you be mad if we wrote 0.5 instead of 1?
Nope, that's fine.
Okay.
All right, actually, let's move my graph grid down here a little bit. Okay, 0.5, 1/2, -1. Got it. Now, vertices. Marking it out. All the stuff. Here we go. I don't love the 5, you don't love the 5. Because if you go to square root 5, of course, it's not a nice number. We've done it enough by now. It's popped up. You probably have this one down. What's the square root of 5 about?
2.2.
Yeah, okay. That's under x, so I'm going to estimate 2.2 right, 2.2 left. Is it going to be exact? No. Maybe. 1, 2.2. Sure. Okay, 3. Square root of 3 doesn't come out nice. I just happen to know it because we use that a lot in geometry. It's about 1.7. Fun. That's under y. So I'm going to try to estimate 1.7 up and 1.7 down. That's, yeah. Okay. So getting it drawn isn't awful. Answering all this stuff is going to be a little awful with the roots, just to warn you. First question for you, okay? Are the vertices the left and right or top and bottom?
Left and right.
Left and right. 5 is bigger. We went more left and right. Now, I need those exact points, okay? So we're not going to freak. We got it. We can do it. We started from the center. Remember, it all hinges off your center. We went left a square root of 5 and right a square root of 5. So I started at a half. I went right a square root of 5 and left a square root of 5. Y is still at -1. Parenthesis. That was fun. Very fun. Length of the major axis. Well, I went right a square root of 5, left a square root of 5. I covered how many square roots of 5? Square root of 5 plus the square root of 5. 2 square roots of 5. That was a little scary. Minor axis. We went up a square root of 3 and down a square root of 3. 2 square roots of 3. We got it, we got it. Foci. Okay, all right, we're going to do the c-squared. I'm just going to scroll this up a little bit so I'm not clear at the bottom here. Okay, foci, c-squared. We're going to do 5 minus 3, of course. We're going to subtract our denominator. Oh, fun, good. Another square root we're going to end up with. Great. Great. That's about 1.4. I just happen to know that. I don't know why. Okay, on the major axis, which was horizontal, so right and left 1.4, ballpark it. I don't know. Okay. Now, they're left and right, so that's off your x coordinate of your center. My x coordinate of the center was a half. I went right a square root of 2 and left a square root of 2. We're still at -1 for the y coordinate. Eccentricity. C over A. Man, we got a lot of roots here. So C, remember, C was our square root of 2. Fun, so fun. What was A? What's your bigger denominator? Square root of 5. And just when you think you're done, we can't have a square root in the bottom. The gift keeps on giving. We're going to rationalize. So square root of 10 over 5.
This is going to take us
Woo!
through your test period.
That was so fun. But think about this, okay? We are covering a lot of different graphs clearly. Circle, parabola, ellipse, and hyperbola. I can't make you do like 4 of each style, you know what I mean? You'll see it's usually like one we have you graph where it's in the form, which you can knock out pretty quick, and then we'll make you do one where you complete the square. And that's usually like 2 problems of graphing per figure, because it is time consuming.
That's a lot of graphing.
It is a lot of graphing. Olivia.
Just to make sure, so for the foci,
Mhm.
if it's going left and right, you put it on the x-axis
Yep.
with like plus and minus.
Yep,
And
exactly.
then up and down, you put it on y-axis.
Exactly.
Okay,
Yep.
it's always like that?
Yep, always like that. We got it. All right, next thing we've got for us, everybody's favorite, writing the equations. Now, of course, as always, I saw some of you did use the scratch graph paper because sometimes I do think it's easier to kind of mark it out and count them. I'm going to kind of draw some little graphs for you to help the cause here if we need. So, nice thing about ellipses, I can kind of set it up here. It's going to be the 2 fractions added. We equal 1. I like it says the center's at the origin. I can do the numerators right now. You don't have any values to put with x and y. I mean, there's 0 technically. So just x squared, y squared. Okay. Now, I'm a picture person, as we all know, so I'm going to just sketch a little graph. So it says right now, let's see, center's at the origin. Got it. And it says the vertices are at 4, 0. I'm not going to mark out all the tick marks. I'm just going to estimate it here. Okay, so let's start with this information. Now, right now I can tell you what A is. Remember, that is the distance from the center to a vertex. How many units are between these? What's 4 squared? 16. Where am I putting the 16? Under x or under y? X. It's on the x-axis. Bam. Yeah. Let's do the foci. I'm going to plot those 2, 0, -2, 0. I'm just going to put an F for foci, so to color coordinate here. Now C, because I mean C, obviously foci, C is the distance from the center to the focus point. Well, either way you cut it, we went 2 left, 2 right. So C is 2. Now you might be like, that's not really helping me, because remember in our equation, which I'm standing in front of over here, b squared. Okay, but b squared's in my foci equation. So I'm going to use my foci equation and see if I can get b squared out of it. So I'm thinking about my c squared equation. Let's jot it down so it's in front of us. Clearly we can square 2. We know that's 16. So I'm just going to do a little algebra and solve for b squared. I'm going to subtract 16 over. I'm not going to freak out that's a negative 12, because what do the negatives do? Cancel. I'm just going to put pluses next to them. I'm not even going to square root it and solve for b or anything. That's it. Because I need it the squared form. B squared's 12, pop a 12 in, we're done. So you really have to know that A is the distance from the center to a vertex. C is the distance from the center to the foci. Let's do another. Kind of like a puzzle. Find the equation whose center is at the origin. Okay, I already know the numerators. I'm going to start filling those in. X squared, y squared, since we're at 0, 0. Ooh, eccentricity. Okay, all right. I like a picture. You know, a picture. So my center, got it. And then the foci, again, I'm not going to mark out all the tick marks, I'm not going to get crazy. 8, 0, negative 8, 0. Now those are the foci. So if you know the foci, are you going to tell me what A is, B is, or C is? C. C is what? 8. From the center to a focus point, 8. Now, I'm like, huh. Okay, that doesn't help me for these denominators. I'm still got to figure something out. But they do tell you E is 4 over 5. Okay, all right, I think I can work on that. So of course we know from earlier that E is the same thing as C over A. So I'm thinking about this, but I'm like, I think I can get you A. Now remember though, RC is 8. So I'm thinking they have 4/5 in some sort of reduced form. Obviously, why wouldn't you reduce it, right? So 4 times 2 would be 8. So 5 times 2 would be, do we agree that 8 over 10 is really 4 over 5? Yeah, it's the reduced version of it. Because we know RC is 8. I have to use 8 for that. But I'm going to use 10 for A. Not the 5, the 10. Because they give it to you in the reduced form. So I now know A is 10.
What was the point of that? Why couldn't we just use...
Say it again, Sophia.
I don't understand what the point of that was.
To get A.
Don't we know it's C over A, so why wouldn't we just use 5?
Well, how are you going to do 8 over 5? Because our C is 8. 8 over 5 doesn't make 4 over 5. I got to use the 8 for our specific problem. So I had to get ingenious about the fraction work. Everybody's favorite. All right, what's 10 squared? Hundo. Where are you putting the 100? Under the X or the Y? X, because we're on the horizontal axis. Yeah, this is a good one. My favorite. Now, of course, we need B squared. But you know C and you know A, so I think my foci equation won't work it out for me. So I'm using my C, C squared, A squared. And I think I already heard somebody say the answer. Subtract 100, you get negative 36. So 36. So the tricky part of this is clearly the fraction work. Because you have to recognize that 4 over 5 is the same as 8 over 10. That's the hard part on that one. All right, one last one, then we'll do some final exam review problems. Vertices of an ellipse. Okay, all right, blah, 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 foci. Oh, okay. So I don't know the center. I don't know if we got some foci, so I might have some C squared. Let's just see what we can make happen here. Okay. So let's start with what they give you. Vertices, negative 7, 3. Again, I'm not going to mark all the tick marks. I'm just going to kind of estimate. Negative 7, 3. And that's a vertex. And then 3, 3. And you can see, I mean, this is not an exact science. This is one where I think, of course, maybe having the graph paper to mark on might be a little Easier? I don't know. Okay. One of the things I need is the center, because I need to know the center for sure, because I need to know the distance from the center to a vertex, A, center to the foci. Well, if you know the vertices, I can get you the center. Isn't the center directly smack dab in the middle? So if I had graph paper, I could just, count it. I'm going to ballpark it. Or, I can't help myself, geometry. I need the point in the middle, aka the midpoint formula.
No. I'm good.
Just bring up geometry or a fraction, the room goes silent. Okay, center, in the middle. I'm just going to average these together. What's -7 plus 3? -4 divided by 2. So I just averaged them. Now, we shouldn't have to think too hard. What's the y? 3. It's on the same line. It's going to be 3. Now, again, you could count that on the graph grid. I can fill in the top. So I'm going to have x plus 2 squared, y minus 3 squared. Let me throw in the equal 1 part. So first off, any questions how I got the center? And again, that's an easy one if you have the graph paper, just literally count what's in the middle, right? Okay, next step. I can tell you what A is now that I have the center. A is the distance from a center to the vertex, one of the vertices, one of them. So if I count from, let's say, here to the right, how many units do you move? 5. From -2 to 3, we went 5. I know you know what 5 squared is. Am I putting 25 under x or y? X. We're left and right. It's horizontal. Okay? Let's see what else we can put on here. Now, I haven't even put the foci on. They also give me that. So, because I'm probably going to have to use that. I'm probably going to use the C. So the foci, -6, 3. I'm going to ballpark it in 2, 3. Now, C is the distance from the center to a focus point. Doesn't matter which focus point, just count it. Or, mental math it. And I'm going to use this guy. So this one was at 3, 3. Or sorry, this one was at 2, 3, 2, 3. That's a very sloppy 2. So to get from -2 to +2, how many units is that? So again, this to me would be a good one. I'd actually maybe mark on graph paper and count, but we should be able to figure out, from -2 to 2, you went 4. Now, I'm going to use my c squared equation. I know, 4 squared is 16. We got that. We got a squared. We can figure out the b squared. Subtract your 25. What's 16 minus 25? Got it. So very fun. Yes? We've got hyperbolas left. That's going to be Friday and Monday. Marking the hyperbolas out are very similar to this. There's just obviously a little twist or slant to it. And then that's just because I know we have AP testing coming at you, next week, and kids are going to be gone. So Friday and Monday is going to be 9-3A, 9-3B, the hyperbolas. Tuesday is kind of this identify the conic day, which it's easy. And then we'll start reviewing for your test, which remember is on Cinco de Mayo.